Welcome to MITRE ATT&CK Defender's Threat Hunting course. I'm Sean Muhlenhauer-Whitley, cybersecurity engineer at MITRE and co-author of MITRE's TTP-based hunt methodology. I'm excited to join my fellow MITRE colleagues in teaching this course. In this segment, we'll cover Module 4, Identify and Mitigate Data Collection Gaps. In this module, we'll be discussing the fourth step of the threat hunting methodology. We'll discuss how to identify our current data collection configuration and based on that, identify any gaps that we may have that need to be filled before proceeding to the next step. Then we will create a plan for addressing those gaps and validate that our new collection strategy is working. Lastly, we will identify any remaining gaps that we have not addressed and explain how those gaps may impact our ability to hunt to the network owner. In this step, we will begin to move up the right side of our threat hunting V. Prior to this, we had developed our malicious activity model, developed hypotheses for detecting those adversary behaviors, and defined data collection requirements that would support implementing those hypotheses. As we move up the right side of this V, we will be gradually building up the solution to the problem we defined on the left-hand side. The first step of which is to begin actually collecting data before building our detections. The first topic we will cover in this module is how to identify gaps in data sensing. This encompasses ensuring the right kind of data is being generated in the environment, that the data is being sent to the analytics platform, and that the data is available to the analyst. This step can be particularly challenging to perform when coming into an environment you are not intimately familiar with. It often involves needing to set up meetings with many people from across the organization, as one person often doesn't have all the answers. While this may not be the most fun step, it is critical to perform in order to understand the environment you are operating in and to maximize efficiency. By the end of this lesson, you will be able to describe how to identify data collection gaps within an environment. There are 5 primary methods we can use to assess gaps in data generation, each one relating to a different aspect. First, and perhaps the most obvious, is to identify what kinds of data are already being generated in the environment. What is generating them, and what are the configurations for those tools? This gives you an as-is picture of the current data sensing available to you. Similarly, we want to collect as much information about the environment as we reasonably can. Specifically, we are looking for things like network maps and generic system information for the devices spread throughout the environment. Ideally, the network administrators would have something like a network topology and system inventories readily on hand, but often this is not the case. We don't need the locations of every single device on the network, but we need to know where things like network boundaries are, where firewalls that might interrupt the flow of data are located, and where is data currently being aggregated, even if it even is, and are there any processing or storage limitations that we should be aware of. Thirdly, we can look at artifacts from any past coverage assessment that may have been done. What exactly coverage means may vary depending on the method used to assess the coverage. Some assessments may look at adversary TTP coverage, which for our purposes would be very useful as it immediately shows us if the detection we want to implement can be done without changing the environment. Others may look at specific capabilities. For example, whether tools like antivirus or firewalls are deployed and where. The important thing here is to try to leverage existing work wherever possible to make your life easier. If we believe the existing infrastructure has the data generation and flows in place that we need, then we can always try executing the TTP ourselves and looking for the expected event in our analysis platform. This method is better suited for TTPs that are sometimes referred to as living off the land techniques. These are techniques that use pre-existing tools in the environment to perform the activity, thus making it easier to get network administrator permission to execute the TTP. And you should definitely get permission before running suspicious commands and programs, lest you worry any other network defense staff. If you don't, it could damage trust with the network managers, making your life harder. Ultimately, all these methods serve to provide you enough information to identify where data generation for the detection we want to write is lacking. There are lots of options for where gaps can exist, but here are some common examples. There is no tool deployed to generate the required data. Or maybe a tool is deployed but is not configured to send the necessary data yet. The data is being generated but not sent anywhere. A firewall is blocking data from reaching the analysis platform, or tools are deployed inconsistently within the environment. So why are we going through all this effort? Why not just tell network managers, deploy this tool for me? The truth of the matter is that unless you are doing this all in your own lab, there are many moving parts and equities that can come into play. By doing your homework, we can build trust with network owners and managers, and they will be more likely to cooperate when requests are well informed. The why of why we need to identify current data sources and configurations is that we need to be able to compare our data requirements against what the current state of data sensors are in the network. This will enable us to identify any gaps that may exist in what we want versus what we need. We do this a variety of ways, a lot of which will involve talking to network managers, network architects, and network owners. Depending on the details of the network, some things to look into is the SIEM, any available configuration files for existing tools, and group policy settings. Some of the things we are looking for in those sources of data are what kinds of data are those data sources making available, where are those tools deployed, and how often and how is that data being collected, if at all. How are those tools currently configured, and for what kind of activity should data be generated? It is important to ask these questions, as we cannot assume that the environment is censored consistently across its entirety. When having these discussions, it can be helpful to keep the time, terrain, behavior paradigm in mind to help inform what questions to ask. Here is a simplified notional network that shows some of the questions we want to ask when assessing the state of data collection in the environment. We have a group of endpoints that access the internet through a router with a SIEM separated off into its own subnet. For the endpoints, we need to assess how many hosts are even out there that we need to defend and collect data from. We need to know what their operating systems are in order to get an idea of what TTPs might be relevant. We also need to know how the various subnets are laid out so we can instrument the network effectively if we are collecting network data. The endpoints send their logs up to log aggregators to be forwarded on to the SIEM. Here, we need to know at a minimum how many aggregators there are and where they are located. Additionally, we should consider getting metrics on how much storage those aggregators have and how often data is sent up to the SIEM. We also need to know which data sources are being sent to each aggregator. This knowledge can be critical in troubleshooting data flows when they are not working. In the middle of it all are the routers that direct the network traffic. Here is where a network map can be very handy. In some situations, we may want to get the routing rules as well, but this is primarily useful for troubleshooting or assessing how an adversary could potentially move through the environment. Facing the internet, we have firewalls and possibly network intrusion detection systems that have insight into network traffic going in and out of our environment. We need to know how many devices there are and how many exits to the internet there are. Noting perimeter devices in particular can help us focus our sensing for exfiltration and command and control techniques. We also need to know what rules are in place so we know what communications can possibly transit the perimeter. Data from all these devices will be going to a SIEM located on a separate subnet from the endpoints. The routers need to be configured to allow the data from across the environment to reach the SIEM. SOC analysts have their workstation on the same subnet as the SIEM to try and keep all security relevant machines secure from any compromises that may occur in the rest of the network. If a threat assessment of the environment has been previously conducted, it might look something like this. This is a heat map of attack techniques and the coverage that the current data sensing provides. An assessment in this format immediately answers our question of whether a data source is generating data for our technique. It is important to note that this kind of assessment still requires us to have thought about how various TTPs can be detected. That is, walking through the process of mapping techniques through the V process to potential data sources. On this diagram, white techniques have no data being generated that address the TTP. Yellow means that the technique is covered to some degree, but not completely. Often this means that certain implementations of the technique are not covered. Green means we are generating data that can detect all implementations of that technique. Since the bar is very high for detecting all possible implementations of a technique, under this metric, most techniques will fall under no coverage or some coverage. The likelihood of having complete coverage is very small. It is important to note that with an assessment like this, that it only informs you what TTP coverage is possible, not what is actually being detected. Some of the things that might not be captured here are how consistently tools are deployed in the environment or consistently configured. This often leads people to believe that they may have certain TTPs covered, but later find out that, for whatever reason, they have no visibility of them. Note that this also doesn't give an indication of the false positive rate, that you may encounter in any existing detections. This kind of visualization is useful for tracking TTP detections as they are developed. As more detections are developed, better and more granular visualizations can be developed to track the organization's detection capabilities. Once this becomes more fleshed out, it can be very helpful at step 0 when determining which techniques to start trying to develop detections for, as it can serve as a guide for what is currently possible and where gaps are. The final method we will discuss for identifying gaps is to perform the activity like an adversary would and see if you can see the resulting events in your data. Some techniques are easily reproducible through commands or actions using tools built into the systems being monitored. Others, however, require using specialized tools that emulate adversary behaviors. There are several tool suites that exist in the commercial world that facilitate this kind of emulation, including MITRE's Caldera, Cobalt Strike, and Metasploit, to name a few. The primary purpose for using these tools is to validate that our sensing deployments and configurations will generate data that we can use to build detections on. In order to effectively do this, we need to have carefully considered what kinds of data we are going to look for back in step 3. If we don't know what kind of data to look for and what that event should look like, we might waste significant amounts of time here looking for an event that doesn't even exist. Conversely, we may also identify additional events that are tied to the adversary behavior that we did not initially consider. It is important to note here that we are not conducting a vulnerability assessment of the system or the network here, often referred to as red teaming. The purpose is just to validate that defenders can see the adversary's actions. Therefore, it might be necessary to temporarily disable a security control that may be in place in order to perform the required activity. Now, you might ask yourself, why would we worry about that if the system prevents it? The answer is simple. We can't assume that just because a security control is in place, that an adversary will be unable to perform the activity. They may disable the security control before performing it, or execute using an unanticipated method. We should always assume that adversaries will find a way to subvert security. Let's review what we discussed in this lesson. We learned some of the steps we need to take to address data coverage gaps and how we can use things like network maps, TTP coverage visualizations, and threat emulations to help assess data coverage.